Welcome, ladies and gentlemen, to your MN19 notes. This is your note guide on special right triangles, which is associated with section 7.4 in your textbook. We're going to need to make sure that we remember how to simplify radicals or square roots before we get into the special triangles. Helpful hint is that this material in the warm-up is from MN5, and really the best way to do this is to pause this video and try it on your own using that MN5 as a resource, and then restarting the video and seeing if what I do is corresponding with what you're doing. So you want to pause the video right now and try it on your own. Thank you for rejoining me. So let me go right through this, see if your answer is corresponding with mine. In this case, I'm going to go 2 times the square root of 3. I'm going to drop those parentheses because sometimes those confuse people. So it's just going to be 2 times the square root of 3 times the square root of 3, which is going to be 2 times, when you multiply the square root of 3 times the square root of 3 right here, that's just going to give you 3. And if you want to do it kind of the long way, you can go square root of 3 times square root of 3 gives you square root of 9, and the square root of 9 is 3. So then 2 times 3 is going to equal 6. So there's my answer for, or simplified form of 2 square root of 3 times square root of 3. Number 2 and 3 are all about rationalizing the denominator, or making sure that there is no square roots or radicals in that denominator. The way we do this, as a reminder, is the square root of 3 in the denominator, you want to multiply it by itself to make that square root go away. What you do to the bottom, you're going to do to the top. So essentially you're multiplying through this fraction by 1, because square root of 3 over square root of 3 is just equal to 1. Now you multiply across, you have 5 square root of 3 in your numerator, over square root of 3 times square root of 3 is 3 in your denominator. Now you for sure cannot go square root of 3 from this denominator and divide it into or under that radical. You can't do that, but you do want to look at those coefficients, or the 5 over 3, and that 5 over 3 cannot be simplified, so that is the most simplified you can get this answer right here, that expression. Number 3, we're rationalizing very similar to number 2. You're going to multiply the square root of 2 on the top and the bottom, just like we did in number 2, but in this case it's square root of 2. You multiply across, so you have 6 square root of 2 over square root of 2 times square root of 2 is 2. And we are almost done. Just like the top, number 2, we're going to look, we for sure cannot divide, again, that denominator of 2 into the square root. But you notice that we have a 6 in the numerator, a 2 in the denominator, and we can simplify that down to 3 square root of 2 over 1. So essentially I'm going to divide this into the 6 by 2, which is giving me the 3. I'm dividing into this 2 by 2, which is giving me a 1. Now you could either leave this answer as 3 square root of 2 over 1, or better yet, just saying 3 square root of 2. Okay, so there's a flash from the past of simplifying radicals. So that really is going to get us into our special triangles. We have really just 2 special triangles, and just kind of keep in mind the whole purpose of special triangles, besides that it comes up later in math with unit circle and a lot of other great things, is that you can solve a triangle for its sides very quickly, super quickly, much faster than using sine, cosine, or tangent, and you can do it using exact values, so there's no rounded answers. The special triangle diagram right here, I have to put in that 30 degrees right here and 60 degrees over here. And the relationship is that the hypotenuse, and I'm going to label these sides here. This is the hypotenuse over here, which is of course directly across in that 90 degrees. Since the 90 degrees is the largest degree in this right triangle, that is why across from it is the longest side. So keep in mind again that those angles are related completely to those side lengths directly across, or the opposite side lengths. So if we look at this, 60 degrees directly across from that, that's the next largest angle. So this is going to be your long side, or we're going to call it a long leg here. So we've got 2 legs and a hypotenuse. We have a long leg, which is directly across from the 60 degree angle, and we have a short leg, which is directly across from the 30 degree angle. And the relationship is that if you have your short leg, So if you have the length of your short leg and you multiply it by 2, that will equal your hypotenuse. So it's kind of like, I don't want to use the word formula, but it is. It's a rule. The other rule is that if you take your short leg and multiply it by the square root of 3, and all of a sudden I'm having some issues with my smartboard here. Short leg times the square root of 3, that's going to give you your long leg. Now, I just want to mention this because, oops, long leg. Ooh, I can do that better. It might seem that the square root of 3 is larger than the square root of 2, but keep in mind that the square root of 3, if you actually put it in your calculator, and I'm going to put this way over here just as a reminder, square root of 3 is actually approximately 1.73 if I'm not mistaken. So notice that 1.73 is clearly smaller than that hypotenuse of 2. So even though square root of 3 seems like a larger number, if you actually found the approximate value, it is just 1.73. I just say that because sometimes students get confused with that. So now if we use those patterns, so I'm just going to really make sure you realize this right here, this is a big deal. You need to make sure that you have these patterns somewhere really close to you so you can use those when we figure out these bottom numbers or value. Okay, so example 1, it says find all missing sides. Now the first thing I would suggest is that you know which side is which. Like this is the hypotenuse, and actually I apologize, let's get some angle measurements in here. Notice I didn't write any of them in. So 30, 60, we're going to keep the triangles in all the same orientation, simply just to kind of get used to the pattern. And then you'll notice that especially when you're working on these, they kind of rotate them and all that kind of good stuff for you to make it a little bit more complicated. But looking at this, we know where our hypotenuse is. Directly across from the 30 degrees is the short side, or short leg, and this is the long leg over here. And by the relationship, it says you take your short leg and multiply it by 2 to get the hypotenuse. Well, to go in reverse, instead of multiplying by 2 to get the hypotenuse, you would divide by 2 to get the short leg. So really, you're going 10 divided by 2, which is going to give you 5, and that is going to be the length of your short leg. So again, the relationship between your short leg and hypotenuse is that it's doubled. So to go in reverse, you would just divide that hypotenuse by 2. The key to these is to make sure you have your short side. So in this case, the short side is 5. Once you have that short side, then you can just multiply it by the square root of 3 to get that long side. So using the patterns up there, short leg times square root of 3 is equal to your long leg. Now this middle example, this time we have our short leg, which is great, because that's what we really, essentially you want to get that short leg first and then find the other missing pieces. I'm going to find, this is the hypotenuse, this is the long leg. So if you're taking square root of, or excuse me, you're taking 10 for the short leg and you're going to multiply it by 2 to get the hypotenuse. So that's going to give you 20 over here. And then to get the long leg, you're going to go 10 square root of 3. To get the length of your long leg. So the long leg's length is 10 square root of 3. You leave it in perfect exact form, square root form, and the hypotenuse is 20. So if you continue this pattern over here, this last triangle, we have this time the long leg, and that makes it a little bit more complicated, but not too much, you'll see. This is the short leg down here. And again, my hint to you is you need to get to your short leg. You need your short leg's length before you find your hypotenuse in this case. So typically you'd go short leg times square root of 3 to get your long leg, but in this case we're going to reverse that. So it's going to be 10 divided by square root of 3. So instead of multiplying it by square root of 3, you're going backwards or doing the opposite, which is going to be to divide by square root of 3. Now, as we talked about in the warm-up, you can't have that square root of 3 in the denominator, so we're going to rationalize this answer, and we end up with 10 square root of 3 over 3. So this short length is 10 square root of 3 over 3. That's your length. Now the hypotenuse we're just doubling. So if you're taking 10 square root of 3 over 3 and multiplying it by 2, you're going to end up with 20 square root of 3 over 3. And if you're kind of confused about that, the best way to explain it is if I take 10 square root of 3 over 3 and I multiply that by 2 or 2 over 1, whoops, that's where you're just multiplying that 10 times 2, which is going to give you 20 square root of 3 over 3. So you're just doubling it. So that actually is the harder of your two special triangles. Now we're going to get to the 45, 45, 90 special triangle. And the first thing, actually, before I even talk about the relationship, I want to make sure you realize that if you have a 45 degree right triangle, which means that we have a 90-degree angle in there as well, this is actually an isosceles right triangle. So if it says you have an isosceles right triangle, that means you have a special triangle. So they will have to tell you whether it's a 45, 45, 90, or it's an isosceles right triangle. Just like the above, they will, other special triangle, they will have to tell you if it's a 30, 60, 90. So they, the book or whatnot will tell you that information so you can use this pattern. But if you look at this one, we've got, since we have an isosceles triangle, we don't have a long or a short leg, we just have legs. And we have an hypotenuse. And the only rule here is you take your leg, whichever one, it doesn't matter, and multiply it by the square root of 2. And that will give you your hypotenuse. So that is your only rule for the 45, 45, 90. So looking at that, I'm going to extend the page here a moment. Okay, so it says find all missing sides. Well, first thing I have to make sure that you have on your note guide is all the information you need. So these are right triangles. I'm going to, instead of writing 45 degrees here, I'm going to just say that this side is equal to this side. As soon as I say that's a right triangle with two equal sides, which is an isosceles, you've got yourself a 45, 45, 90-degree triangle. This one I'm going to write 45 degrees here, which then concludes that this other angle, the other acute angle, is 45 as well. So it says find all missing sides. Well, if my one leg is 10 on this left triangle, that means my other leg is 10. And you know what? The hypotenuse is as simple as saying 10 times the square root of 2. So 10 is one leg, 10 is the other leg, 10 square root of 2 is the hypotenuse. Now this last example, the hypotenuse is given to us instead of the leg. So instead of multiplying 10 by square root of 2, we divide by square root of 2. We undo that multiplication, so we reverse it. So we have 10 over square root of 2. Of course, we can't leave it like that because it's naughty to leave a square root in the denominator, so we're going to rationalize it. And we have 10 square root of 2 over square root of 2 times square root of 2, which is 2. And we can go one step further, and we can see that 10 over 2, which is going to give me 5 square root of 2. So this is 5 square root of 2, and this is 5 square root of 2. And that is it, ladies and gents. We have a 30, 60, 90-degree triangle, and we have a 45, 45, 90-degree triangle, and tomorrow we'll be practicing this in class. Thank you for tuning in.